Hey guys, so welcome back. In the previous video, I was talking about the design of the various parameters for OFDM system. In this video, I mainly focus on the design of subcarrier spacing, that is ZF, right? So in the previous videos, I was taking the example of bandwidth 10 megahertz. This is a wider bandwidth. The moment we take the wider bandwidth in case of wireless channel where there are multiple components, we experience severe ASI. The reason is that the symbol duration is far less than tau d. Okay, this we had seen in the previous videos. I will not go through that, but to mitigate this ISI, what did we do? Okay, first is that let's say this is a 10 megahertz bandwidth. Now, if you see the channel frequency response, then you will see that it is not flat for this complete bandwidth because of ISI, right? But the moment we divide this entire bandwidth into smaller subbands, for this smaller subbands, we can say that we can experience the flatness in the channel frequency response, right? But the question here is how to choose the size of this subband, right? So the moment we divide this into subband, we need a certain condition to remove the ISI. That condition is our symbol duration should be far greater than tau t. This is a condition, right, to remove ISI. And if you remove that ISI, then we can say that this particular subband experiences the flat channel frequency response. And we know that the symbol duration is related to the subcarrier spacing with this. So definitely how can we write? So okay, definitely the first condition is that the symbol duration should be far greater than the tau d. And this is related to tau s is related to the subcarrier spacing by this formula. What about this one? This is a delay spread, right? In the frequency domain, it is related to coherence bandwidth, the duration over which the channel frequency response is flat, right? So definitely if we have the channel response flat for this much duration, definitely the subcarrier spacing, whatever we consider, should have a width much smaller than this, right? It should not be more than this. Then for this entire width of the subcarrier, the channel is not flat, right? It might be not flat, but if you consider this much is the flatness, our subcarrier width should be taken such a way that it experience the flatness of the channel. So how can we write this expression? So this is the first condition. So if I want to write this using the frequency values, then delta f should be far less than the coherence bandwidth, right? I hope this is clear. Now we will move to the second constraint. See, I was telling that the symbol duration should be far greater than tau d, right? This is going to reduce the ISI. But how much large value we can consider this? Let's say if I consider earlier I used to consider something like this, and if there is a delay spread of this much, okay, then that much, whatever is the delay spread, that much overlap is there between the first path second symbol and lth path first symbol. This is the overlap, this much is the ISI, right? But if we take if we take this symbol duration much larger, let's say this, I will take this much larger, then for the same tau d, you will see that for this larger symbol duration, only a small portion is having the overlap, or only a small portion would experience ISI. This is better, right? But can we design something like that? So what constraint we would get? The constraint is that uh, we might have time varying channels, right? Where the channel conditions might vary much faster. So the symbol duration should not be so much large such that the channel condition itself will vary, which means that my symbol duration should be, I would say, it should be uh, less than or equal to, I would say, TC parameter. TC is nothing but coherence time. Okay, this defines the duration over which the channel is constant. Okay, so my symbol duration should be chosen such a way that it should be within the coherence time. Okay, so this coherence time is related to the frequency parameter, that is nothing but BD, which is Doppler spread. Okay, so I mean, this Doppler spread, how we can represent, let's say, I have transmitted one subcarrier over here with the frequency, let's say, f. Then because of Doppler spread, we can see the signal not only at f but at f plus delta or f minus delta, on these ranges as well. We can see the signal, right? That is a Doppler spread. But if you have chosen this width of subcarrier delta f, see here you can see, right, that this delta f should be actually greater than, you can say, greater than your, let's say, this is the delay spread PD. Okay, this is a condition. But if delta f itself is smaller than BD, then it will cause a lot of distortion, and it will also contribute to the inter-carrier interference, and the carriers might lose orthogonality, and it will be difficult to recover the signal. So I hope this condition is clear. Even from here also, what we can derive is, um, you know since this is related to 1 by delta f, this will become delta f, and here we saw, right, so delta f should be far greater than BD. So combining the two conditions, it will be like delta f should be far greater than BD. Then it should be, where is my first condition, it should be far less than the BC. This is a condition. This is how we should derive this. I mean, this is how the value of delta f should be chosen. Okay, so in terms of time, T symbol should be greater than TC. Okay, then this should be for sorry, T symbol should be far greater than TD. Okay, then it should be far less than TC. I hope you got the clarity of how to choose this. Now we will see what has been chosen in case of 4G. Okay, 4G, the delta F is chosen as 15 kilohertz, which means that the symbol duration is 66.67 microseconds. What about the typical delay spread? Typical delay spread is of the order of 3 to 4 microseconds. So definitely the T symbol is far greater than tau d. Okay, so and what about coherence time? So this coherence time is, in case of OFDM, so it is for about, let's say, minimum for about 7 symbols, we consider the channel can be constant. Yeah, in a high Doppler case, it will be a problematic. That's why we will say that we will limit even what high speed we can support in case of 4G. In case of 4G, we support up to 100 kilometer per hour speed between the receiver and the transmitter. So based on this, up to 7 symbols, the channel can be constant. Uh, this is like TC is for greater than 7 times T symbol duration, right? So the things are taken care in case of 4G based on this design. I hope things are clear. If you're looking for more videos, please do subscribe to the channel. Thank you very much. Have a great day. Bye bye.